All right, this video is going to talk a little bit more about functions. We've already discussed what the definition of a function is, so here are just a few examples to remind us. Notice the mapping diagram over here for part A. What we want to do is tell whether or not the pairing is a function. Well, if we take a look at all the inputs, all the x's, each one of them seems to go to one place. Even though 0 and 3 both go to 2, 0 goes to 2, 3 goes to 2. Each input has its own output. So therefore, I would say yes, that's a function. Over here at the right, on the other hand, part B, notice that the input 0 goes to both 1 and 8, and 4 also goes to 8 and 12. So therefore, no, because they both have two outputs, it would not be a function. The graph down here at the bottom, each of our points comes from a specific x value. X was -2 for this first point, 0, 2, and 4. And for each of those x values, there's only one point on the graph. Therefore, I would say, yep, that's a function. Versus the graph at the right, notice over here when x is 3, we get values of 2 and 6. Notice the labeling. We get values of both 2 and 6. Because that value at 3 has more than one output, that wouldn't be a function. Now, rather than just defining a function though, what can we do with a function? A lot of times, one of the major things we do is graph. Graphs are a great way to represent a function. So in order to graph a function, first of all, we need a function. Up top here, we've got y equals x plus 4 with a domain of 1, 3, 5, and 7. So notice they've limited our domain. We're only going to plot essentially 4 points. So step 1, what we need to do is use our function to find the range. A great way to do that is make a table. So I took 1, 3, 5, and 7, put them in for my x values. Go ahead and plug those into my function. Well, 1 plus 4, right? 1 plugged in for x here. 1 plus 4 is 5. 3 plus 4 was 7, and so forth and so on. And then all I have to do is plot my points. So you'll notice on my graph down here at the bottom, I've got my x values labeled, I've got my y values labeled, and again, I just plotted my points. X along the bottom, Y up the side, and I even put a lot of labels on there. We wouldn't really need all of those labels as long as we can count the lines and something is labeled. So let's talk a little bit more about graphing. Go ahead and do an example of graph. So we've got a function up here at the top, y equals 15 minus 2x. We also have a domain given to us in the table of 1, 2, 3, 4, and 5. So what we want to do first of all, again, is plug those 5 numbers separately into our function. So 15 minus 2 times 1, 15 minus 2 times 2. Notice I'm just taking out the x and I'm plugging in the values that I was given in the domain. 1, 2, 3, 4, and 5. So now all we have to do is calculate. 15 minus 2 times 1, so 15 minus 2 would be 13. 2 times 2 is 4, so 15 minus 4 would be 11. So forth and so on. 15 minus 6 is 9. Then we've got 8, so 15 minus 8 is 7. And 15 minus 10 would be 5. Once I've got those numbers, I sort of have my coordinates. I want to plot the points. Now you'll notice the y values started out fairly large. So one note we want to make is we want to make sure the scale on our graph means that we can plot all of our points. So I need to make sure I can get to at least 13 on the y-axis here, on this vertical up and down axis. But at the same time, I don't want 13 to happen way at the bottom. You know, if I counted by tens or something like that, 13 is going to happen way down here, and I'm going to have a lot of extra graph up here. So I want them spread out enough that I can see all my data, but I also want to make sure I can see all my data. So thinking about 13 and the fact that I've got 10 lines on my graph, why don't we go ahead and count by 2's? So when I go to make this graph, I'm going to go ahead and say, well, my x values were 1, 2, 3, 4, and 5. We can either go by 1's, or technically, you could count by 2's if you wanted to. We would spread 5 out to this end of the graph then. But I'm going to go ahead and count by 1's here. But I'm going to go by 2's, making this 4, 6, 8. This would be 10, about halfway up. And technically, I could reach 20 up here at the top. Well, now I can plot the point. Again, the ordered pair, 1, 13 is going to be my first point. So since 10, 11, 12, 13 should put me right about there, that looks like a good point to plot. And then in the same way, I'm going to go ahead and use my calculator or my screen to kind of help me out. I know I've got 5 points. I'm just going to move them into place here. So I know that I need to plot my next point at 2, 11. Oh, those are kind of in the way here. Let me move these points out of the way. Just a little easier than drawing. But again, if this is 10, but this was 12, 11 is going to be halfway. We want to plot 3, 9. It's a little bit below 10, but not quite down to 8. 4, 7. Again, also halfway in between those two good lines. And 5, 5. So again, this was 2, makes 4, 5, before I reach 6 there. Now, you might be tempted to draw a line. Because they limited our domain, because our domain was only 1, 2, 3, 4, and 5, we don't want to draw that line. Soon enough, later on in the chapter, or maybe later on in the year, we may get to the point where we draw that line, and we'll have a reason for that. But with a limited domain, using only the given 5 numbers, we only want to plot the given 5 points. Now, one last thing that we can do with functions is, what if we're given the graph, could we go backwards? And the first thing I would recommend if we're going backwards and finding its domain and range and finding its rule is go ahead and write the points down. I'm going to start off by saying I've got x and y, I've got x and y, and I'm going to find these points. So again, if we start with that first point up top here, notice according to the labels, if this is 2, then this must have been 1. So I'm going to count backwards. 1, 2, 3. I'm at -3, and we're up at 2 here as far as that goes. Same thing goes. Again, we're at -1's -2, and we never went up and down, so that would be 0. I'm at -1, down 1, 2. So we're at -1, -2. And finally, 0, -4 appears to be our last point. That means technically our domain starts at -3, -2, -1, and 0. And our range started at, well, the lowest really is -4. And I'm going to count my way up to 4. Now, if you misorder that, that's not a huge ordeal, but it is nice to write them in order if possible. But now let's take a good look at what's happening here. And this is just going to take some practice. Sometimes these are harder than others. So again, if we want to write that rule, and sorry, I know it's a little off the screen there. If we want to write a rule for the function, I need to look at my numbers and decide, how can I make -3 into 2? Maybe just adding 5. But wait a minute, -2 plus 5, would have been 3, not 0. So that didn't really work. So I might have to get a little bit fancy here. Now, if you remembered yesterday, we had an example where if things are going to change in the y values, a lot of times multiplication can help. So every time my x values went up by 1, right, -3, -2, -1, 0, my y values are going down by 2. So sometimes that helps if we talk about multiplication. So I'm going to say y equals -2x. Because now if x were 1, I would be at -2. But if x were 2, I'd be at -4. My number went down by 2. We decreased by 2. Only problem there is, again, if I plug in that -3, -3 times -2 would have been 6. I'm 4 too high. But let's see if that works for the next one. -2 times -2 is 4, which again is 4 higher than 0. -1 times -2 would have been 2, which is 4 higher than -2. Well, if I'm 4 units too high every time, why don't we just subtract 4? Now let's see if it works. In fact, let's start at the bottom of the list. 0 times -2 would have been 0. -4 is -4, which is exactly what we wanted. Let's go back to the beginning. -3, right, times -2 would have been 6. minus 4 would be 2. So that seems to work. Looks to me like we've got an answer down here. Again, that's going to take some practice. Play around with the numbers a little bit, and we'll come up with a lot of really good rules again later in the year. This is pretty early. These may be difficult, but give it your best. And if you need any help, talk to your teacher. Good luck, and have a great day.